Okay, good evening, all of you.
Good evening.
So, few more to join. Kemit, this lesson is regarding states of matter. If you want to join, that's fine. Like this is
Yes,
not regarding ionic bond. These are like the basic lessons which we already discussed. But if you want to stay, that's totally fine.
sir. Tomorrow, like the exam is there, so
Ah, okay, okay. Then that's fine. Vituli is yet to join. Like, however, we have to start. The time is 6:05, and we are finishing at 8 as well. So, I want the response, and welcome to the second day as well. I want the response from one of you who were there in the previous class. Uh, we discussed up to freezing, right? Can one of you confirm? Sanuja, can you confirm? Like, we discussed only up to freezing, right?
So today we have to do from the
Boiling, right?
changing state between liquid and
Yeah.
gas
Yeah.
from
That's
that
it.
topic.
Okay. So I told you to do certain homework. So can we discuss the homeworks? Hands up who have done like using the raise hand option. Give me a response. What about Sandil? Sandil, have you done the homework? Okay, that's fine. So before starting the second session, quickly, like I'll do a recap of what we have discussed so far. And I also went through the recording. I saw like you can raise your hand down. So I also went through the recording in certain places. I noticed like when I was using green color, it is somewhat hard to see my letters. So if you like experience such kind of situations, please let me know. Okay, and then and there I can correct. Like otherwise, you will write something which is wrong. So it is not good. So I'll discuss like what we have discussed so far. When we consider the first lesson that is regarding states of matter. States of matter in here like firstly we discuss regarding their arrangement and like using particles how we draw solids, liquids and gases. So when we consider solids like in particle arrangement, you need to draw the particles like touching each other, and through your diagram, like it should showcase a regular arrangement as well. So I'm not going to draw those things again and like waste the time. So then when we consider liquids, particles are mostly touching, but here and there, you need to show the gaps between the liquid particles. And through that diagram, it should showcase like some kind of a random arrangement, not a regular arrangement. And in gases, we discussed like particles are far apart, and when you are like drawing the particles of a gas, also like you need to show like there can't be a regular spacing. Yes, particles are far apart, but between the particles there cannot be a regular spacing, like uh, you need to show some kind of a random arrangement again, although the particles are far apart. Then we discuss certain details, although that is not in the textbook, that is in grade 8. I mentioned to you, like we discussed certain details regarding kinetic theory as well. So based on the kinetic theory, there are three main findings. One is spacing, then in spacing we discuss like whatever the type of matter, regardless of the type of matter, there is always a spacing. Like of course we know in gases there is a pretty much space, liquid space is there, solids as well, even though there is a tightly packing in solid particles. In a solid, the particles show tight, particles are tightly packed, yet like there's a small spacing exists in solids as well. So first point of the kinetic theory was spacing. Then second point was forces of attraction. Why the solids are tightly packed? Because they are having the strongest forces of attraction. Then liquids are somewhat loosely packed because force of attractions are somewhat lower compared to solids. It is like moderate. Then in a gas, particles are far apart because force of attractions are like almost lost between the particles. Then in particle theory, we discuss spacing, force of attraction, and the movement. So again, like in any kind of matter, particles are moving. Of course, we discuss regarding movement, like in liquids, particles are moving around each other. In gases, particles are moving in random directions in very high speeds. And even in solids, we discuss there is a vibration. Vibration is also a type of movement. We discussed these details. So basically, we were discussing about arrangement, movement, and the kinetic energy of these three states of matter and how we showcase the arrangement using particles. Then I moved to interconversions in matter. In interconversions of matter, we discuss all the interconversions, but I like elaboratively discuss up only up to the freezing part. So when we consider interconversions, like conversion of solids to liquid, that is called as melting. Then liquid to gas, that is considered as either evaporation or boiling. Then when we consider the other direction, from gas to liquid, that is condensation, and from liquid to solid, that is freezing. And there is some part which we are learning new in grade 8. I mentioned to you, like there are certain, in certain kind of matter, without bypassing through the, like without going through the liquid state, certain matter directly transfer from solid to gas, which is considered as sublimation. And the reverse of that process is considered as either deposition or desublimation. Okay. So we discuss about the interconversions of matter, and in there I mentioned to you, like when we are moving in this direction from solids to gases, so it always involves absorption of heat, and when we are moving the other direction, it involves the like loss of heat or either cooling process. Okay, so those are the details we discussed. Then as a homework, I told you to do certain questions. Can one of you mention to me, like what are the questions which I have given to you? I'll ask from Chanuka. Can you tell me, Chenuka, right? Yeah, Chenuka, can you tell me what are the questions which I have given? Question number 1, A, B, as I remember. Chenuka, can I have a reply? What are the questions which I have given to you? Anyone? Sanujo, Sandil, can you? Okay. 1 A, B, 2, 3, 4, right? Okay, thank you for the message. And I have like Sainit is there. Sainit, this is like regarding states of matter. If you want to join, that's fine. Like otherwise, we have done these lessons. Okay. So if you want to stay, that's totally fine. You can stay. So 1A and B, I have given to you. Question number 1, complete the diagram to show how particles are arranged in the liquid state. Then this should be the diagram. In markings, they are always stating particles should fill from the bottom of the container. Particles should fill from the bottom of the container, and it should showcase some kind of a random arrangement, and there should be gaps between the particles as well. But most of the particles are touching each other. Okay. So I told you in drawing this kind of diagram, at least you need to draw like 3 to 4 rows. Minimum is 2, at least draw 3 to 4 rows. I'll read the marking guidelines. These are the guidelines. Particles should be close together and should fill from the bottom of the box. That is one marking guideline. So more specifically, they have mentioned regarding these details. Then most particles should touch with a minimum of 2 random rows. I mentioned to you there should be a minimum of 2, but for the safe side, better you draw like 3 to 4 rows at a minimum. Then they have mentioned ignore the size of the particles. They don't really care about the size of particle, but since that is of same like we are considering one kind of a like liquid, right? So in a one kind of a liquid, particles should be of same size. So better you draw the particles of the same size, although that is not expected in the marking. Then reject a regular arrangement through your diagram. If it like if it shows some kind of a regular arrangement, your diagram will be rejected. You won't be given marks. So that is regarding question number 1, Roman number 1. Identify the state of matter that contains particles with the least energy. So when we consider 3 states of matter, the state of matter which is having the least movement is the solids only show some kind of a vibration. So that is the state of matter which is having the least energy or least kinetic energy as well. So the answer should be solid. Then B part, the table shows 2 changes of a state. Complete the table by giving the name of each change of a state. Solid to liquid, that is melting, and solid to gas, that is sublimation. So these things we discussed in the last week. Then question number 2, the box shows some changes of state: boiling, condensation, evaporation, freezing, melting, and sublimation. The table lists some physical changes. Complete the table using words from the box to show the change of state for each physical change. Physical change, water to ice, which means from liquid state to solid. Liquid to solid conversion, that is freezing. Steam to water, so a gas is converted to uh, a liquid, which means condensation. Solid wax to liquid wax, solid wax to liquid wax, so a solid is converted to a liquid, that is melting. And iodine crystals to iodine vapor without passing through the liquid state. Directly iodine converts from solid state to gaseous state, which is sublimation. Okay, so again I'll repeat the answers. For the first one, it is freezing. Second one, condensation. Third one, melting. And fourth one, sublimation. Then question number 3. Use the word from the box to identify the changes of a state X, Y, and Z. So X is converting of a liquid to gas, which is you can take evaporating. Why gas to liquid condensing and liquid to solid is it that is freezing. Okay. Again, I'll repeat the answers. Evaporating, condensing, and freezing. Okay. Then describe the differences in the movement of particles in solids and gases. So in solids, particles vibrate, and they are asking about solids and gases. In gases, particles will move randomly in all directions at very high speeds. So those are the things you need to mention. Then question number 3 done. Question number 4, give the change of state that occurs when a substance melts, that is melting. Change of state is during melting solid to liquid. Complete the word equation for the sublimation of iodine. You might not know about these physical states. So this will be taught to you in the lesson of chemical calculations, but I'll just mention a small note regarding that one. So by now you might know about these things, but if you don't know, you can learn. They give me 1 second. Okay. So and during the meeting, don't switch on your mics. So there are 4 states. One is solid. S will stands for solids. Then next one is I'll consider liquids. Then G for gases. And AQ for aqueous. If you don't know, you can write. Aqueous means when something is dissolved in water. Dissolved in water. So I'll take some examples. A piece of magnesium is burned in oxygen. So you will get to know how you write these formulas later in the lesson of mainly ionic bonding. So it will form magnesium oxide. Okay. So in writing equations, you need to balance the equations as well. So I'll put 2 here and 2 here. Magnesium is a solid. So normally, like underneath the element, you need to, on the right hand side, underneath the element, you need to mention the physical state. These are called as physical states of elements. Then oxygen is a gas and magnesium oxide is a solid. I'll take another example where copper will react with sulfuric acid, H2SO4, and it will form copper sulfate. And actually, copper does not react with sulfuric, so I'll take another metal. So you will get to know about these things like why copper is not reacting with sulfuric in the lesson of reactivity series. Magnesium react with sulfuric, it will form magnesium sulfate and hydrogen gas. So magnesium is a solid, sulfuric acid is a aqueous solution. So we can mention as AQ. Magnesium sulfate, again, can consider as a aqueous solution. Hydrogen is a gas. So this is how you represent the physical states. You don't need to know about these things. Just remember there are four physical states. S for solids, L for liquids, G for gases to represent the gaseous state, and AQ for aqueous when something is dissolved in water. Or for solutions, you can use the symbol AQ. So here they have given complete the word equation for the sublimation of iodine. Sublimation. Iodine will directly move from solid state to gaseous state. Iodine vapor. So this should be gas. Then the circle in the diagram represents a particle. Complete the diagram to show the arrangement of particles in a gas. Particles in a gas, very simple. Here there is a particle. Then you can have they mentioned number of particles? No, right? The circle in the diagram, yeah. Certain questions they mention how many particles you can use. Okay. So in this case, they have undefined. So you can have this kind of a diagram. Then the table lists some statements about the particles. Place ticks in boxes to show which two statements are correct for water particles. The particles only place ticks in boxes to show which two statements are correct for water particles, liquid state. Then the particles only vibrate, that is wrong, that is in solids. The particles do not move, that is also wrong. The particles have no gaps, that is wrong. The particles move randomly, yes, that is correct, random movement is there. Particles have more energy than in ice, yes. Particle movement is higher in liquids than solids. So that is correct. The particles have a regular arrangement, that is wrong. So the correct statements are statement 4 and 5. With that, we can conclude the discussion of questions. So if you are having any questions, you can send it to the chat. I will check the messages if you are having any questions. Sandil, why you didn't have the note? Like you didn't join last week? You joined, right? As I remember. So you need to take a hard copy, Buddha. So I'm putting the like tudes to the group, no? So you need to share it to a communication and you need to take a hard copy and be ready for the class. So please come to the dude changing state between liquid and gas. changing state between liquid and gas. The first point is not there. Please write. Boiling occurs. Boiling occurs. Vituli, we just started after the discussion. So we are in the tube changing state between liquid and gas where we stopped last week. So I'm going to read the point which is relevant to the first bullet point. So please write under boiling, first bullet point. Boiling occurs when a liquid is heated. Boiling occurs when a liquid is heated. Michelle, ini recording එක චුට්ටක් stop වුණාද බලන්න ටොට්ටොක් ගාලා සද්දයක් ආවා. Sorry. Recording එක චුට්ටක් stop වුණාද බලන්න. Audio එක දාලා දෙන්න. Okay. 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 Sorry, like something happened with the recording. That is why I stopped. Okay. Okay. Then, right, boiling occurs when a liquid is heated so strongly that the particles are moving. If you miss something, please let me know. Then I'll read it again. Boiling occurs when a liquid is heated so strongly that the particles are moving fast enough. To overcome all the forces of attraction between them. To overcome all the forces of attraction between them. The stronger the forces of that part is there, right? In the tube. Then write the last point. The temperature at which a liquid changes to a gas. The temperature at which a liquid changes to a gas. Is called as its boiling point. The temperature at which a liquid changes to a gas is called as its boiling point.
Sir,
Yes.
can you repeat the last parts of the first one?
First one. A boiling occurs when a liquid is heated so strongly that the particles are moving fast enough to overcome all the forces of attraction between them.
Thank you, sir.
Okay. So please go through the tube. I'll do some kind of explanation. Like we have discussed these things already, but I want to emphasize one point, especially the third point. Boiling occurs when a liquid is heated so strongly that the particles are moving fast enough to overcome all the force of attraction between them. Like when we consider solid, liquid, and gas. So in here, like the most important part is in under this topic, you need to understand, like I told you, moving from liquid state to gaseous state, that can be either evaporation or else boiling. Either evaporation or boiling. What is the difference between these two? We will learn that in the evaporation part especially. Okay, so that is the main thing which you need to learn here. But in this case, what they are telling us, a boiling occurs when a liquid is heated so strongly that the particles are moving fast enough to overcome all the force of attraction between them. So when something is becoming a solid, like when something is becoming a liquid from solid phase, here very strong force of attraction, then to some extent force of attractions are loosened, then when it is moving to gases, force of attraction is either completely broken or like it is very weak attractions between the particles. So that is what they are explaining. Then the stronger the force of attraction between particles, the higher the boiling point of the liquid. This is because more energy is needed to overcome these force of attraction. Then, if like we consider two liquids, A and B, we will assume in A the forces of attractions are weak to some extent. So I'm not referring to gases. I'm referring to two liquids, and compared to B, A is somewhat weak. Otherwise, like force of attractions are somewhat moderate, like considerable amount is there in liquids. That is why particles cannot get rid of the attraction forces. Although some flexibility is there over the movement, like they can move around each other, but still in contact. Okay. So considering when considering two liquids compared to B, consider A is weak and this one is strong. Okay. So since the force of attractions are stronger, we need to provide more energy. Can you see this part? Yes. We need to provide more energy for B. As a result, boiling point, the temperature at which a liquid converts to a gas, BP, not blood pressure. Okay, boiling point. The temperature at which a liquid converts to a gas, the temperature which this happens, that is considered as the boiling point. Boiling point is higher since we need to give more energy. That part you need to remember. So here force of attractions are weaker. As a result, we need to provide less energy to overcome the force of attractions. So as a result, boiling point will be lower in A compared to B. Boiling point will be lower in A compared to B. So that is what they are explaining in that point. Then, if a gas is cooled, the particles eventually move slowly enough that the force of attraction between them start to form and hold them together as a liquid. So, when we consider gases, in gases, particles are moving in random directions at very high speeds. How it become a liquid during the cooling process? That is what they are explaining. So when we cool a gas, what will happen? Earlier they are moving at very high speeds. Consider this as a gas particle. But during the cooling process, During the cooling process, what will happen? Particles will become slower. Particles will be slower. So their kinetic energy will be slower. In this case, so I told you in a gas, I don't know whether I mentioned you this point. In a gas, when particles are moving, in grade 8 book also this is there. In a gas, when particles are moving, particles are forming two types of attractions. Two types of collisions in a gas. When due to particle movement, two types of collisions happen in a gas. Can you tell me like what are those two types of collisions which happens in a gas? If you know the answer, just send it to the chat. Send it as a private message where others cannot see. Then otherwise, like others will also see your answers. In a gas, my question is in a gas, when the particles move, there are two types of collisions. Collisions means they will do some kind of when they are moving, they hit with each other. That kind of a meaning, collision. So what are the two types of collisions? So I'll open the chat. What are the two types of collisions? I'll ask these kind of questions time to time. Otherwise, like you won't engage with me. So to have that engagement, like I'll ask these kind of questions. Can you send me the answers? What are the two types of collisions which you can see? Anyone? Okay, I'm not getting in. Okay, one answer I received. No, that is a different thing. Okay, in collision, elastic and non-elastic collisions are there. That will be learned in physics actually. Okay, in here, what I expected was when we consider a gas during the movement of particles between particles, which means one gas particle will collide with another gas particle. That is one type of collision. Other collision is gas particles are having an impact on the walls of the container which they are in. Okay, gas particles are having collision with the walls of the container in which they are in. So what I wanted to discuss about collisions is, so especially during the cooling process. So when the particles state in the gaseous phase, although gaseous particle collide, they will again like move away from each other. But that happens due to since their movement is very high. So, but during the cooling process, the movement of these gas particles, the speed which they are moving, it will gradually lowers down. Then in that case, when they collide, like it is near to the this happens near to the condensation point. Condensation point means boiling point means the temperature at which a liquid converts into a gas, the temperature at which a gas converts to a liquid, that is the condensation point. So near to the condensation point, what will happen? Actually, at the condensation point, what will happen when they collide? They are having very slow movement now. When they collide, they form attraction between the particles. Then particles get together and convert back to the liquid, then falls onto the bottom of the container. That is how from a gas again a liquid is forming. if you understood that, like if you understood my explanation regarding like during cooling process, how a liquid forms from a gas. If you understood that thing using raise hand option, can you give me a response? Okay. Okay. Hi, Vishli. This is regarding the states of matter. So actually, we are in the like ionic bonding in the physical class. So if you wish to join, that's fine. Otherwise, like there is no requirement. Especially, I'm sharing these links to physical class group as well. The reason is some students have joined the class lately. That is the reason. So if you wish to be in the class, that is totally fine. So I'll erase this one. If you want something to write, please write it down. The next point. In boiling, heat or thermal energy causes bubbles of gas to form inside the liquid, allowing for liquid particles to escape from the surface and within the liquid. Okay. In here, I would like to emphasize some kind of a difference between evaporation and boiling. I'll take two situations where the temperature is around like 40 Celsius and there is there is a water beaker. So this is water. I'm going to mention you regarding the differences between evaporation and boiling. Although we can use these both terminologies, both terms for this interconversion of matter from liquid to gas, there are clear-cut differences between these two processes. So I'm going to explain a bit regarding that. So here, again, there is a water beaker, but in this time, this is at the boiling point of water, which is 100 Celsius. Hands up, like using raise hand option, you can respond. If you think, I'll consider this as A, setup A, and this one as B. In which setup you think the conversion of liquid to gas, that interconversion will happen? In which setup, in either A or B, you think whether the conversion of liquid to gas, that interconversion will happen? So you can respond. So I'll be looking at the chat. You can respond accordingly. In AOB, the interconversion from liquid to gas will occur. Okay, I see some responses. I need the responses from all of you, especially the four students in the online class. Okay, only Sandil, I'm receiving responses from Sandil only. Why? I need the responses from Chenuka, Vituli, and Sanuja as well. I need your answers as well. In which beaker you would think like interconversion of states happen from liquid to gas in AOB. This is a water beaker which is at a temperature of 40 Celsius, and this is a water beaker which is at a temperature of 100 Celsius. Chenuka, I received the answer. Sanuja, I received the answer A to B. Sanuja, your answer is not clear. A and then A to B. There can't be that kind of an answer. Okay. Then who else didn't reply? Okay. 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 Some are saying A and some are saying B. Definitely in this speaker, mostly like your answer is B. Definitely at boiling point, water will convert into a gas. Water will convert into a gas. That is of no question. So I'll take a simple example. When your mothers like wash the clothes, when your mothers wash the clothes, like unless they are not using, like in certain Colombo areas, they might use dryers, like the laundry facilities will be used if you are in some kind of like residences. Okay, unless they are using a dryer, what is the normal process of drying clothes after washing? You let them into the sun. So sun drying will be used. So in there, are you heating clothes up to the boiling point of water? No, right? So still, what will happen? Water will go away from the clothes. So what happens there? Evaporation. Evaporation. So in this one, at the boiling point, what will happen? At the boiling point, boiling will happen. Boiling will happen at any temperature, even at the room temperature, which is considered as normally 25 degrees Celsius, at any temperature below the boiling point, what will happen? Evaporation happen. Evaporation happen. So in both A and B, interconversions of matter will happen from liquid to gas, liquid to gas. So that is one of the differences regarding evaporation and boiling process. So boiling happens at exactly the boiling point of the particular liquid, and evaporation happens at any temperature below the boiling point. Then evaporation happens from the surface of a liquid. From the surface of a liquid. Boiling happens from the surface or else from within the liquid. So when a liquid boils, you can see bubble formation inside the liquid as well. So definitely all of you might have used a like hot water kettle. So in using a hot water kettle, then definitely you might have seen the generation of gas bubbles inside the kettle as well. Okay, inside the kettle as well. So gas bubble formation will happen, or this interconversions or the boiling, during boiling, this gas formation, bubble formation will happen inside or within the liquid and from the surface as well. Okay. But when we consider evaporation, can it happen within the liquid? No, it will happen always from the surface of the liquid. Actually, like how evaporation will happen. If you want to find the details, like better you search and learn, but I'll give brief insights how evaporation exactly happen. In a liquid, particles are moving at certain speeds. So particles are having kinetic energy. Out of the normal particles, certain particles are having a high kinetic energy, where when they come to surface, that energy will be enough for them to move from liquid to gaseous phase. The particles which are having a higher kinetic energy, when they are coming to the surface, that energy will be enough for them to get rid of that attraction force in a liquid. That is how evaporation exactly happens. In boiling, all the particles in a liquid, even within the liquid also, they are having enough energy for that phase conversion from liquid to a gas. One difference regarding temperature. And in boiling, it happens at the boiling point of a liquid. In evaporation, it will happen at any temperature below the boiling point. Boiling happens within and from the surface. Evaporation always happen from the surface of the liquid. Okay, those are the main differences. We'll go through the tube. Please look at the fourth point. In boiling, heat or thermal energy causes bubbles of gas to form inside the liquid, allowing for liquid particles to escape from the surface and within the liquid. Can you see? Please highlight liquid particles to escape from with a green color, allowing for liquid particles to escape from them, that part with the green color, and with a yellow color from the surface and within the liquid. From the surface and within the liquid. From the surface and within the liquid. Then highlight the last sentence with the green color again. The temperature at which a liquid changes to a gas is called as its, that part with green color. Then with orange color highlight boiling point. The temperature at which a liquid changes to a gas, that is easy. Then evaporation. I already discussed about evaporation. Let's read the tube. I think I have given the first point. Evaporation. In any liquid or gas, the average speed of the particle varies with the temperature, but at each temperature, some particles will be moving faster than the average and others more slowly. Some very fast particles at the surface of the liquid will have enough energy to overcome the force of attraction between the particles. That is what I mentioned. The particles which are having like somewhat higher kinetic energy, they are having enough energy to get rid of the attraction forces. Please highlight some very fast particles at the surface with green color. Some very fast particles at the surface of the liquid will have enough energy with a yellow color to overcome the forces of attraction between the particles. To overcome the force of attraction between the particles, they will break away to form a gas. This is called as evaporation. Highlight evaporation with the orange color. These have four highlighters: orange, pink, green, and yellow. Then evaporation occurs only at the surface of liquids. Please highlight with the green color. Evaporation occurs then with yellow color only at the surface of the liquid. Only at the surface of the liquid, where high energy particles can escape from liquid surface at low temperatures below the boiling point of a liquid, and highlight with pink color at low temperatures below the boiling point of a liquid. At low temperatures below the boiling point of a liquid with pink color. So I think that second point is not there, no? Yeah, in your tube that is not there. So to save the time we are doing for only 2 hours, no, from today onwards. So to save the time, I'll send those 3 points to the group as a homework. Please complete that part. Please check the group. I'll be sending it now. All the points relevant to evaporation I'll send to the group. The last three you need to write at home. Please look at the tube. Evaporation occurs only at the surface of liquids where high energy particles can escape from liquid surface at low temperatures below the boiling point of a liquid. Evaporation occurs over a range of temperatures. The larger the surface area and the warmer the liquid surface, the more quickly liquid can evaporate. I'll give you a small break of like 2 to 3 minutes. You can like freshen yourself. At the same time, try to write these 3 points as well. Try to write these 3 points because there are certain things we need to highlight. So time is 7:01. We'll meet at 7:05. Yeah, that's enough. If you have written the note, please highlight. High energy particles can escape from the liquid surface at low temperatures. Liquid surface that high energy particles can escape from the liquid surface with green color and with yellow color at low temperatures below the boiling point of a liquid. Okay, that's enough. Then they are discussing about the factors which is affecting evaporation. One is surface area, and other one is the temperature. These kind of small notes, if you can add, that would be better to your notes. And as a homework, please do a comparison between evaporation and boiling. Those questions they might ask in papers. Do a comparison between evaporation and boiling. So you can mention the temperature, and you can mention from where it happens, within the liquid or surface, from the surface. Like that, include those points, and better you write it in a sticky note and paste it to the tube itself. And for future lessons, like I will, there are certain updates which I want to mention to you. Like in future lessons, I'll try to send the tutor as a book. Definitely, it will be possible. And with regards to practicals, normally what I did was like I was sharing the certain links in the YouTube. But in future, I'm contacting a chemical lab as well, so I'll be able to record the practicals in a lab, and I'll be able to share those details into you, like as YouTube recordings maybe. Okay. And sometimes like definitely in future, I believe like the number will increase when the results come. I'll do some other promotions as well. So when the number increases, definitely it will increase. And when the number will increases, I'm going for an LMS, like where you can do like all the payments, and where I can upload like all these videos and practical videos at one place. You will be able to have all the things to go for that kind of investment. Like I need a bigger number of students, so like I'm planning all the things in future. So don't worry, like I'll try my best to give you a better experience, although this is an online class. Definitely with regards to practicals, there's a very high possibility I'll be able to do those things and give the recordings. Okay. Then next one is condensation. When a gas changes into a liquid, usually on cooling, when a gas is cooled, its particles lose energy, and when they bump into each other, they lack energy to bounce away again. Can you remember? I told you during the cooling process, gradually their kinetic energy will reduce, and at the condensation point, when they collide, they won't have enough energy. When they collide, they will form attractions, and they won't have enough energy to bounce away again. Okay. Instead, grouping them together to form a liquid. Can you please highlight with a green color when they bump into each other? When they bump into each other, which means when they collide with each other. When they collide with each other. Then with a yellow color, they lack energy to bounce away again. They lack energy to bounce away again. That is regarding condensation. Then changing state between solid and gas. All the 3 points you have to write there, no? Okay. So, please try the first point. When a solid changes directly into a gas, when a solid changes directly into a gas, when a solid changes directly into a gas, that is the first point. When a solid changes directly into a gas, that is called as sublimation. That is called as sublimation. This happens, second point, this happens to only a very few solids. This happens to only a very few solids. This happens only to a very few solids, such as iodine, iodine, O, O, solid carbon dioxide, that is considered as dry ice as well. You might have heard the term dry ice, that is solid carbon dioxide. This happens to only a few solids, such as iodine, O, solid carbon dioxide. If you miss anything, please let me know. Then third one, the reverse of this process, the reverse of this process, which means the opposite process of this one. The reverse of this process is called deposition. Spellings will be there on the board. The reverse of this process will be called deposition or else desublimation. Desublimation. Actually, in here the topic should be sublimation and put a hash and write deposition as well. The topic sublimation, put a slash and write deposition. Both are in the same topic. Okay. So nothing to discuss there. We already discussed. Then that part is over. We have discussed the questions as well. There will be further quizzes. I'll be giving to you as homework. So please do them. And if you are able to have the tutes which I have uploaded, sorry, I forgot to upload the tutes earlier. But in case if you are having the hard copies of the tutes which I have uploaded today, raise your hand. If not, that's fine. If you are having the tutes, all of them, then yeah, that would be great. Vituli? Okay. All the tutes which I uploaded, you are able to have the hard copies, right? Great. Yeah. Take the tute 2. Tute 2. Chapter 1, Tute 2. Predicting physical state of a substance. Very interesting part at a particular temperature. The physical state of a substance under certain conditions can be predicted from a given set of data, melting point and boiling point. A substance is a solid at temperatures below its melting point. Between its melting point and boiling point, it is a liquid, and above its boiling point, it is a gas. Then we have to predict the physical states of the given substances. First, let me. Okay, you can raise your hand down. Okay. Firstly, let me explain that to you. Predicting the physical state. Physical state, I'll mention as PS. Physical state at a particular temperature. At a particular temperature. Very small thing, like nothing much. Please listen very carefully. When we consider particular substance, first thing you need to know as a data, you should know about this thing. That is melting point. I'll mention as MP and boiling point. Melting point means the temperature at which a solid will be converting into the temperature at which a solid will be converting into a liquid. Higher than the melting point, this will be converted to a liquid. Below the melting point, it is a solid. This is the melting point. Below the melting point is a solid. Boiling point. Boiling point means the temperature at which a liquid is converting. A liquid is converting to a gas. Below the boiling point, definitely like when you are heating water also, below the boiling point, it stays as liquid water. Above boiling point, boiling will happen and it will be in the gaseous phase. In between melting and boiling point, so at the melting point, solid will convert to a liquid. At the boiling point, liquid will convert to a gas, which means in between melting point and boiling point, that will stay as a liquid. This is the simple theory. I'll take an example. Here, better you draw a number line when this kind of a question is given. Better you draw this kind of a line. Mark the melting point. I'll take as an example water. Freezing point of water is 0 degrees Celsius. Boiling point is 100 degrees Celsius. That is a fact. We already know. Then you know below 0 Celsius, you know what is there? Ice will be there, which is the solid state. Ice. Above 100 Celsius, that is forming the gas, which is considered as a steam. Then from 0 to 100, it will be in the liquid phase. As water. I hope the theory part is clear to you. Using raise hand option, can you please give me a feedback whether you understood the theory? Sanuja and Vituli, I'm waiting for you to as well. Okay, great. Put like you don't need to raise your hand, like since others are raising the hand. If you don't understand a particular point, even after the class, you can give me a you can either send me a text message or voice message. that's fine. Like then when I'm having a free time, I'll give you a call, or either I'll send you a voice message as well. Okay. So don't hesitate to ask the question. So definitely in learning science, if you don't ask questions, I believe like you are not learning properly. I told you in the very first day as well, in learning science, you should have curiosity. Okay, don't accept the thing which I am telling to you. You need to question yourself and myself as well. That is totally okay. Okay. So that open communication should be there between us. Like at any time, you can contact me. Like a lot of students are asking questions from me. The ones who are in the physical class, they are used to ask questions because I'm always motivating them to ask questions. If they don't ask questions, I will ask from them. But in a online class, it is hard to like pinpoint one person and ask the questions. No, that is why I'm not asking questions. I can do that, but it will consume our time. Physical classes we started on May, so we had enough time to do it very slowly. So in like in online class we started on the last week. I need to make you ready for the monthly test as well. Lot of content to be delivered within these 2 months, 3 months. First monthly test will be on October. I'm referring for the ones who are in Lyceum especially. The first monthly test will be on October. Second monthly test will be on November. Then so on. And for the first monthly test, there will be uh, like 7 lessons in the like principles of chemistry. Unit 1, altogether 10 lessons are there. Unit 5 and 6, they will ask for the November monthly test. Unit 10, you will learn in the second semester of, sorry, third semester, or the third term of grade 9, you will learn unit number 10, which is electrolysis. Apart from those three, 5, 6, and 10, all the other 7 lessons will be there on the October monthly test. Okay. So I'll try my best to make you ready for that as well, although we start the class later compared to the physical classes. So, like in each question, I have left a space to draw this kind of a line. Okay, definitely you follow this process. Okay, in these kind of questions, it will be easier for you to get an answer using that method. So above the tube, like on top of the tube, there is some space above the chapter 1 tube 2, that topic. There is some space on top. Can you please mention this part? That is enough. Okay, this part, this is the basic theory, no? So I have already given that as a statement, but better you have this kind of a drawing as well. I'll give you only 2 minutes. Hurry up. To save the time, we will do just question number 1. Okay, question number 2, 3, and 4 will be homework. We will discuss on next day. Then we will quickly move to the diffusion as well. Since you are having the tute, I'll try to finish diffusion also to some extent. Then it would be easier. Who the like who have joined from Trinity College, Sandil? Can you give me some idea, like on when you are having exams, like have you started already like that? Can you give a small like kind of introduction how the things happening at Trinity College?
So we just finished second term.
You just finished second lesson,
Second term, sir.
second term, right? My goodness. So which means you have started in Jan, right?
Yeah, yeah.
Okay. So it is operating like CIS and these schools. So at the moment, in which lesson you are in, Sanil?
Metallic bonding, sir.
Metallic bonding. Okay.
Sir.
So I'll finish some lessons quickly, so you don't need to worry. Like, however, by next December, we'll finish the syllabus, and I'll start the paper class around January as well. So we are having like 1.5 years to practice the papers, and don't expect an easy paper at all, because the trend is like the papers are getting harder and harder. The last time paper 2026 June, very hard, I told you in the first class as well. 2025 November also a very good quality paper. So they are maintaining a good standard nowadays. So we should be ready for that kind of a standard paper. So definitely don't worry. I'm not only taking questions from Edexcel. I'll be taking very good questions from Cambridge and Oxford as well. And apart from that, I'll be making questions as well, model questions. Try to do question number 2. If you understood the concept, I'll give you 2 minutes. That is enough. Try to 3 minutes I'll give you. Try to do question number 2. We'll just discuss one question, then we'll move to the theory part quickly. Normally in physical class, I'll discuss much questions. Since we are like having some kind of a delay, so we will do less questions, and rest of the things will be homework, and we'll move to the next theory. So I'll be giving you 3 minutes. Question number 2, you need to do regarding oxygen. Melting point of oxygen is minus 280, like that. That question. Once you are done, like please give me a response using raise hand option. Then I'll start. So I'll start doing that thing, otherwise we are running out of time. Melting point of oxygen is minus 218 and boiling point of oxygen is minus 183. Melting point is minus 218 Celsius and boiling point minus 183. If we heat oxygen from minus 300 to minus 100, predict the physical state of oxygen at following temperatures. Temperatures are there on the next page. First one is minus 300. On this side, I'll write those temperatures with a different color. Minus 300, 200, 125. Minus 300. Minus 200 will be here. Minus 100. And room temperature means 25 Celsius. 25 Celsius. They are asking us to predict the physical state. So you need to mark this one as melting point. That is easier. Then this one as boiling point. Okay. Then higher than the boiling point, that stays as a gas. So this one and this one belonging to the gaseous state. Minus 100, it is a gas, and 25 degrees Celsius, which is the room temperature, that is a gas. Minus 200, in between melting point and boiling point, that is a liquid. Okay. So then minus 300, less than melting point, which is at the solid state. Those are the answers. Hands up who got correct answers. Can you raise your hand if you got all these things correct? Okay, let me see. Okay, what about Sanuja?
So I can understand.
You can't understand,
No, sir, I can understand.
but like you couldn't do it at the first time, no?
Yes, sir.
Okay, try to do the homeworks properly, Sanuja.
Okay, sir.
If you haven't written this thing, can you please take a screenshot? Then you can copy it down later.
So I wrote.
Okay, okay. Well done. So please do the other questions at home. We'll move to the diffusion. Please take the tube number 3 regarding diffusion. So I have uploaded to the group the completed tube to save our time. Let's go through the tube. First of all, we will have a discussion regarding what exactly diffusion is. Already you know this concept in lower grades also. You are learning about diffusion. Okay. Diffusion. So what is diffusion? For an example, I'll take this kind of an example. Assume like I'm doing a physical class and I'm having some students around me. So I'm using a perfume before the class. Then I come to the class. Like after some time, the definitely like the students very near to me, they will like perceive the same smell. Then after some time, it will take some time for the smell to or the odor to reach the like backbenches or the students who are at the back of the class. So it will take some time. However, so when I use a perfume in the class, the others also can have that same perception with regards to the odor or the smell. How that happens? Through the principle of diffusion. Through the principle of diffusion. What is diffusion? Diffusion means the movement of particles from a region of higher concentration. Earlier, like in my example, when I use a perfume, so some liquid droplets are coming into my shirt, right? So there's a higher concentration in here. Then with the time, what will happen? Firstly, from liquid phase to liquid particles cannot move like that. So firstly, from liquid particle, these liquids which are used in perfumes are very volatile. Volatile means they will evaporate very quickly. So firstly, these liquid particles will evaporate and then they will diffuse. Diffuse means here there is a higher concentration of particles. In other places in the class, so there is a lower concentration. From higher concentration to a lower concentration, the particles will move. Movement of particles from a region of higher concentration to a lower concentration is considered as diffusion. You already know this concept, so I'm not going for much details. Even in lower grades, this is being taught. So assume this is where I'm standing in the class. Then after some time, the people who are in the front rows will experience. Then after some more time, the ones who are in back rows also will experience this thing, because from liquid phase to the gaseous phase, particle will there will be interconversion. Then the gases will diffuse from a region of higher concentration to lower concentration. So that is considered as diffusion. This is a simple example where I can explain you the concept in very simple manner. Okay. So please highlight the word diffusion. Please highlight the word diffusion with orange color. Then highlight with green color. Is the spreading out of particles? Is the spreading out of particles? Spreading out of particles. Then with a yellow color, from where they are at a higher concentration to where they are at a lower concentration. From where they are at a higher concentration to where they are at a lower concentration. And always, like with regards to these kind of definitions, try to have it to example and understand these things, rather like by heart in these definitions without knowing the meaning. That is useless. Then for diffusion to occur, particles must be able to move. Therefore, diffusion does not occur in solids. In solids, particles just vibrate. They cannot move from one place to another. So it is very like uncommon for in solids to have diffusion. It won't happen. Diffusion won't happen in solids, since the particles cannot move from place to place, only vibrate in fixed positions. Very easy. Diffusion can occur in liquids and gases, since the particles in these gases, these states of matter, are able to move, collide with each other and spread out. Okay. So in liquids and gases, diffusion will occur. Please highlight solids in pink color. Sorry, yellow color. Solids, yellow color. Then in the second sentence, liquids and gases, yellow color. Then with green color highlight, diffusion does not occur in the first sentence, diffusion does not occur in green color, solids, yellow color. Then second sentence, diffusion can occur in green color, liquids and gases, yellow color. Simple. So I have indicated certain diagrams as well. You can see the color diagrams there, where certain examples diffusion happens. Okay. Then there is some kind of experimental setup to demonstrate diffusion and certain factors also affecting diffusion. Actually, in here we are discussing two factors which is affecting diffusion but not relevant to this experimental setup. But in here we are dealing with one factor which is relative molecular mass of the gaseous particles, and there is another factor which is temperature. Normally, when the relative molecular mass, will discuss what exactly is the relative molecular mass. When relative molecular mass becomes higher, the rate of diffusion will be lower, and when temperature is higher, rate of diffusion will be higher. Those are the two factors which are going to discuss. One factor will be discussed in this experimental setup. First, we will try to understand what exactly happening in this thing. I will use these two colors, brown and purple. Can you tell me like whether these colors are visible to you properly? Okay, right? Using raise hand option, can one of you like confirm? Okay, two of you already, your hands are raised. So can you please lower down that thing, and can one of you confirm? Even like you can unmute and tell me like whether these colors are visible properly to you. Chenuka, is this like these colors are visible to you? Okay, okay. So this side in your diagram, that is ammonia solution, and that side hydrochloric. I think your diagram, this is not there. So can you please use two colors? So here, like this color should extend up to like near to the HCl end, and this color only up to here. Please use two colors, and these are gaseous particles. Please show these two gases. It will give you a better understanding. And I haven't given the chemical reaction for that thing. Please write below this diagram the chemical reaction as well. What will happen here is ammonia gas and HCl gas will react and form ammonium chloride. And this is ammonia gas, and this one is very important. This is not hydrochloric acid, and this is hydrogen chloride. This is a gas. I'll explain you what is the difference. Hydrogen chloride gas. Here this is called as ammonium chloride. Okay. HCl I'll mention as acid solution. Okay, that's it. Here white ring is ammonium chloride. Quickly write. We'll continue until like 8, 10. So just to finish this tutor, then like first lesson is almost finished, except the solubility part. Solubility part I'll be taking later. So in Lyceums also that part is taken later because it needs some kind of a maturity for you to understand that concept. So don't think like I'm skipping those areas. That is not that kind of a thing. So you need some maturity to understand that thing. So we'll discuss that later. Then I'll be moving to the second lesson from next week onwards. And all the questions of diffusion will be homework. For diffusion also I have uploaded a tute. I'll mention you the tute. There's a tute called as QT2. QT2 regarding questions of diffusion. There are 5 questions. Please do these questions as you know. Okay. Your answers might be wrong. That doesn't matter.
Sir,
Yes.
What is the word under the cotton wool?
Cotton wool, this one soaked in. So
Okay,
I
sir.
you
Thank
don't
you,
need
sir.
to write that thing that is already there in the tube, right?
Okay, sir.
Okay, cotton wool with concern soaked means like it is dipped in HCl solution. Okay, ponga thing, that is the meaning. Okay, I hope you have completed now. Please look at the board. Here, there's a glass tube. Then two corks are there on the either side to have some kind of a sealed environment. Otherwise, what will happen? Like these gases will move out of this tube. So to avoid that, like they have used certain bungs. Then two cotton wools are there on the either sides. This has been soaked in HCl acid solution, which means you dip the cotton wool in HCl acid solution, hydrochloric acid solution. So then this cotton wool has been dipped in a ammonia solution. Okay. Then what will happen when you let the setup like this? From so this is a solution, hydrochloric acid solution is there, HCl aqueous. Here that is HCl aqueous. From this solution, what will happen? HCl gas will form through evaporation. Through evaporation, HCl gas. This is not hydrochloric acid. This is called as hydrogen chloride. You will learn about hydrogen halides in the lesson number 12 under the halogens. So in there, we will have some kind of a chat. Okay, these are poisonous vapors. These things we will discuss later. For the time being, remember, this is not the same thing. This is HCl acid that is as a solution. From that it evaporates and forms a gas. This is hydrogen chloride gas. Okay, so big difference. Then the gases from a region of higher concentration to a lower concentration, it will diffuse. From this end, same thing happens, evaporates and forms ammonia gas. So this is ammonia aqueous. Ammonia solution is ammonia aqueous. From this one, ammonia gas originates through evaporation. Then what will happen? Ammonia also diffusing through the tube. Then they will meet at a common point. When these two gases will meet, they will react with each other. This is the corresponding reaction. Ammonia gas react with hydrogen chloride gas, forming ammonium chloride, which is a like some kind of a like white smoke will be formed. That is considered as white ring. So this white ring formation occurs due to the formation of compound ammonium chloride. Ammonium chloride. Again, I will tell you, this cotton wool is soaked with HCl acid. This cotton wool is soaked with ammonia solution. Through evaporation from both gases originates from this end hydrogen chloride gas and this end ammonia gas. And in here, not at the middle portion, now more towards HCl end. So this white ring will be formed closer to the HCl and we will discuss why it is forming like such. Okay, that is relevant to one factors which is affecting for diffusion. So we'll discuss the reason why it is formed away from the ammonia end and closer to the HCl end. However, so here at this point where both the gases meet, they will react with each other. Ammonia gas react with HCl gas, forming ammonium chloride, which is a white ring. Okay. So I hope that part is clear to you. Can you please give me a response using raise hand option if you are okay with that? Okay, right? Yeah. Then let's move into the tube and see like what they are talking about in the tube. We'll continue the discussion a bit, like around 10 minutes more to complete the diffusion part. In theory class, it took around like 3 days for me in here. It was successful. Within 2 days, we were able to finish the content. Rate of diffusion of gases. Rate of diffusion of gases depends on two factors. Two factors have been given later in the tube: the relative molecular mass of the particles and the temperature. Before that, after the experimental setup, please read it. Cotton wool soaked in ammonia solution is put into one end of a long tube at A below. Please cut at A below. That is not relevant here. Please cut that. It gives off ammonia gas. At the same time, cotton wool soaked in hydrochloric acid is put into the other end of the tube. At B, please cut B as well. It gives off hydrogen chloride gas. Okay. Please highlight with green color cotton wool soaked in ammonia solution. Then with yellow color highlight ammonia gas. Ammonia gas. You need to clearly know about the difference. Then with green color again highlight cotton wool soaked in hydrochloric acid. Then with yellow color highlight hydrogen chloride gas. Then the gases diffuse along the tube. White smoke forms where they meet. The white smoke forms closer to B. Better you mention they are closer to HCl end. Closer to HCl end. So the ammonia particles have traveled further than the hydrogen chloride particles, which means they have traveled faster. They have traveled faster. Then the two factors, the relative molecular mass of the particles. First of all, we learn about relative molecular mass in chemical calculations in lesson number 5. In lesson number 5. Before that, in this lesson also, you should have some kind of idea. If you can remember like this, that would be much that would be more than enough. So consider like this. In here, from hydrogen chloride, this is having a higher relative molecular mass. This is having a higher relative molecular mass. Consider those gases are heavy gases for the time being. This gas is a heavy gas. Heavy gas means relative molecular mass. In short form, I'll write RMM, relative molecular mass. Consider relative molecular mass is higher if a gas is heavier. If the relative molecular mass is lower, those gases can be considered as lighter gases. If it is a lighter gas, relative molecular mass is lower. Relative molecular mass gives some kind of an idea regarding the, I would say like at this level, like consider as like weight of a gas. So in this case, hydrogen chloride is somewhat heavier, so relative molecular mass is higher. If something is more heavier, it is having a lower tendency. It is having a lower tendency to move faster, which means it will be moving slower. When relative molecular mass is higher, it will be moving slower. When relative molecular mass is lower, a lighter gases can move faster. Lighter gases can move faster. That is why like it is moving a higher distance. That is why this ammonia is moving a higher distance compared to HCl. When HCl gas is reaching here, ammonia has reached this kind of a distance. Okay, when HCl gas travels like a shorter distance, ammonia has from here to here, it has moved in the same time. In the same time. Suppose we may think for HCl gas to reach here, it will take around 30 seconds. In 30 seconds, in the same time, ammonia has reached here. So, when the relative molecular mass is lower, lighter gases in simple words, they will move faster and they will travel further at the same time compared to the gases which are having a higher relative molecular mass. That is the basic kind of a definition which I can give it to you. We'll learn it in a broad manner, like what exactly that is in the lesson of chemical calculations, which is the fifth lesson. The lower the relative molecular mass of its particles, the lighter the particles. So the particles will move faster and the rate of diffusion will increase. When they move faster, the movement of particles from higher concentration to lower concentration is considered as diffusion. So the rate of diffusion means like the speed of diffusion. Okay, the speed of diffusion will be definitely higher. The larger the relative molecular mass of the gas particles, the heavier the particles, so the slower the particles will move and the rate of diffusion will be slower. Can you please give me a response if you understood the first concept, first factor regarding diffusion, how relative molecular mass is affecting the rate of diffusion? Okay, I believe you can understand that. Then the temperature. So this practical is conducted at a room temperature. Room temperature is considered as a standard. It is considered as 25 Celsius. Assume the same practical, same setup was kept in some kind of a chamber, closed chamber, where we can regulate the temperature, and we will change the temperature up to around 45 Celsius. We'll change the temperature, which means we increase the temperature up to 45. At a higher temperature, what will happen? Particles will gain more kinetic energy. At a higher temperature, particles absorb that thermal energy and they will reach, they will have a more kinetic energy. So they will move faster. Not only ammonia, HCl also, like at the same temperature, what matters is relative molecular mass. When relative molecular mass is lower, lighter gases will move faster and the other gas will move slower, the heavier ones, or the gases which are having a higher relative molecular mass. At higher temperatures, both these gases, not at the same speed, but in both of the gases, relative to room temperature, which is 25, definitely since they are acquiring more kinetic energy, they are gaining more kinetic energy, the speed in which they move will be faster and the rate of diffusion will be faster, and the white ring will form at a lesser time. So when the temperature increases, the rate of diffusion will increase, in simple words. Let's read the last one. When a gas is heated, its particles take in heat energy and move faster due to increased kinetic energy. Highlight move faster with the green color, with yellow color, due to increased kinetic energy. They collide with more energy and bounce further away, so the gas diffuse faster. The higher the temperature, the faster a gas will diffuse. Okay. So with that, I would like to conclude the session for today. And the homework, again, I'm reminding to you, list down the differences between boiling and evaporation. Do the questions in predicting the physical states at a particular temperature. That too, all the remaining questions, I think around 3 to 4 questions are there left. Only we could do one question. And diffusion tube, there's a tube called as QT2. In that, all the diffusion related questions are there. 4 or 5 questions are there in the tube. Please complete all. And in next day, we'll learn about first I'll discuss all the solubility will be taken later. Some part of like basic kind of an understanding is relevant, needed, relevant to the solubility. I'll start with that because that concept is needed when we discuss the crystallization process in the second lesson. So I'll be moving to the next lesson, which is elements, compounds, and mixtures. Okay, so don't miss the classes. The relevant tubes will be uploaded. I'll try to compile all the tubes into one booklet kind of a thing, and I'll share it with you. Okay. Then until we meet again on next week, have a nice weekend ahead. Okay. Goodbye.
Bye, sir. Thank you, sir.
Thank you, sir.